Hello students, welcome once again to our channel Score High to Soar High. In this video series, we have been seeing derivations of Class 12 Physics Lesson 1 Electrostatics. Today we are going to see the 12th derivation in this series. Come on, let us see the derivation. Before that, don't forget to subscribe and share this channel with your friends and neighbors. Derivation number 12, energy stored in the capacitor, or derive an expression for energy stored in the capacitor. Answer: when a battery is connected to the capacitor, electrons of total charge minus Q are transferred from one plate to the other plate. As we all know that in a capacitor, it has got two parallel plates. So when a battery is connected to it, electrons get transferred from one plate to the other. To transfer the charge, work is done by the battery. This work done is stored as electrostatic potential energy in the capacitor. To transfer an infinitesimal charge, that is a very small charge dq, in a potential difference V, the work done is given by dW is equal to V dq. Let this be equation number 1. And as we all know that the expression for capacitance is nothing but C is equal to Q by V. Therefore, V is equal to Q by C. Let this be equation number 2. Now, substituting equation 2 in 1, that is, I am going to substitute the value for V in this equation. So, in the place of V, I am going to substitute Q by C. So, we get dW is equal to Q by C dQ. So, this is the expression for a small work. Now we are going to calculate the total work done. So from smaller to bigger, so we need to integrate this equation. So integration of dW is equal to integration of Q by C dQ. The lower limit is 0 and the upper limit is Q. Because in the beginning no charge is transferred, so let it be 0. This is taken as the lower limit. After some time, some charge Q has been transferred, so the upper limit is taken as Q. Here, this 1 by C is taken out because C, the capacitance is constant. So, integration of dW is equal to 1 by C, integration of Q into dQ. So, what is the value of integration of x dx? First, let us know the value of integration of x dx. Then we'll come to this part. Here a note is given. Integration of x to the power of n dx is equal to x to the power of n plus 1 divided by n plus 1. So here in our case, integration of q dq. Q means what? Q to the power of 1. Which is equal to Q to the power of 1 plus 1 divided by 1 plus 1. So we get Q to the power of 2 divided by 2. Now let us come to this. So here when we integrate Q dQ, we get Q squared by 2. Here integration of dW is nothing but W. So W is equal to 1 by C into Q squared by 2, and the limits are 0 to Q. So which is equal to 1 by C. So first let us substitute this Q in the place of Q. So Q squared by 2 minus, again we are going to substitute this 0 in the place of Q. So we will get 0 only. So W is equal to Q squared by 2 into C, 2C. So this is what the expression we get. But this work done is stored as electrostatic potential energy. So in the place of W, I am going to write capital UE, that is potential energy is equal to Q squared by 2C. Let this be equation number 3. Again, let us write the common expression for capacitance. Q is equal to Q by V. Therefore, Q is equal to CV. Let it be equation number 4. Now, substituting equation 4 in equation 3. In the place of Q, I am going to substitute CV. So, what do I get? UE is equal to, in the place of Q, I have substituted CV. So, CV squared by 2C. So, in the next step, C squared V squared by 2C. So, this C squared and C get cancelled. So, we will get C over here. So, in the next step, CV squared by 2, which can be written as half CV squared. Here comes another expression for capacitance, which is nothing but capital C is equal to epsilon naught A by D. Again, we have got an expression for potential difference V also, that is V is equal to E into D. So now we are going to substitute these two values in the previous expression. Therefore, UE is equal to half C. So in the place of C, I have substituted epsilon naught A by D into V squared. In the place of V, I have substituted ED. So ED squared. So in the next step, half epsilon naught A by D into E squared D squared. This D and this D squared get cancelled. So we get D over here. So in the next step, UE is equal to half into epsilon naught, and this A and D, I have written it in bracket, within bracket, so AD, and finally E square. So this is the expression for potential energy. UE is equal to half epsilon naught AD into capital E square. With this derivation has come to an end. Let us meet in the next video with another set of derivation.
Like, share and comment and subscribe our channel and click the bell button for more videos. Thank you.